All right, 5th grade Excel, lesson 56. We're going to figure out how to find the area of a rectangle today. Earlier, we learned how to find the perimeter of something. That's the measurement around the outside edge. Now we're going to find how to measure the inside of the shape. Up to now, we have been measuring the length of lines. For a new type of measurement, surface area, we use square units. Surface area is the size of a rug, a wall that needs paint, or a field that a farmer will plant. 1 square inch is a square that measures 1 inch on each side. How would you describe a square yard or a square meter? Well, let's talk about this. If a square inch is 1 inch, 1 inch, 1 inch, 1 inch on each side, then a square yard would be 1 yard on this side by 1 yard by 1 yard by 1 yard, and a square meter would be 1 meter by 1 meter by 1 meter by 1 meter. Okay, so it says use your centimeter ruler with this rectangle and draw in the centimeter lines to describe the area in terms of square centimeters. So I want you to go ahead and take your ruler and draw across there, draw down here and down there on your own paper. Now, how many square centimeters covers up this shape? How many? Well, the answer would be 6. So there are 6 square centimeters in the area there. Looking at the rectangle, the lines form 2 rows of square centimeters with 3 squares in each row. So you have 3 this way, and there are 2 down this way, right? Can you see a way to compute the area of a rectangle if you know the length and the width? If I told you how long this side was, which is 3 centimeters, and how long that side is, which is 2 centimeters, can you figure out the area of the inside? Remember, the answer was 6. How do you do that? Well, let's take a look. What you're going to do is do a multiplication problem that involves the length, right, times, we're going to multiply that by the width. Length times width is equal to the area. So there's your formula right there. Go ahead and write that. And, well, that's what they want down here below. That's okay, either way. Just write length times width is equal to the area. All right, numbers 1, 2, 3, and 4. Here we go. We're going to do this first one together. How do we find the area of this shape? Well, this side is 5 and that side is 5. So to find the middle, to find the area of the square, we're going to multiply one side times the other. So we're going to write 5 times 5. And the answer is 25. Don't forget to put square kilometers. Remember, these are not kilometers. They're little squares on the inside of this shape. Pause the video, try number 2, turn it back on when you're ready for the solution. All right, you should have written 8 times 2. You always have to show your work. The answer is 16 square yards. 16 square yards, right? Okay, do numbers 3 and 4. Pause the video, turn it back on when you're ready for the solutions. For this first one, you should have shown 4 times 3, length times width. That's equal to 12 square feet. And on this next one, you should have done 6 times 2, which is equal to 12 square feet. All right, those last two have the same answer. Look at that. And it says, compute the perimeters for numbers 1 to 4. What do you learn from this? And we've already done these 4 problems, so now we're going to decide what can we learn from these shapes here. Well, the perimeter for number 1, actually we haven't done that yet. Go ahead and calculate the perimeter. Pause the video, turn it back on when you're ready to see the solution. Do the perimeter for all 4 of these shapes, okay? Well, the perimeter of number 1 is 20 kilometers because 5 plus 5 plus 5 is 4 5s. The perimeter for this one is 8 plus 2 plus 8 plus 2. That's equal to 20 kilometers. No, 20 yards. Sorry, 20 yards. Perimeter for number 3, 4 plus 3 is 7. Plus 7 more is 14 feet. Hopefully you got that before you saw me give the answer. And here we have 8 plus another 8. That's equal to 16 feet as well. Okay, so what can we learn from seeing this? Well, let's take a look. This has, and this, both have a perimeter of 20. Okay, but the area of this one is 25 and the area of this one is 16. That's interesting. Well, on this one here, the area is 12 and the area of this one is also 12, but the perimeter of this one is 14 and the perimeter of this one is 16. What can you tell by look at, well, here, look at, the perimeters are the same, areas are different. Here we have the area is the same, perimeter is different. What do you know about that? What can you tell from rectangles from doing that little experiment? Pause the video, see if you can fill this in, turn it back on when you're ready to see what my solution was. All right, what I'm going to say about it is the perimeter can be equal without the area being, and you don't have to have this exact same thing written as me, but something like this maybe, without the area being equal, and vice versa, which means the other way around. In other words, we can have the area being equal, but the perimeter not being equal. Just because two shapes have the same area doesn't mean they're going to have the same perimeter. Just because two shapes have the same perimeter does not mean that they're going to have the same area. All right, that's it. So thanks for watching.